Here we go again, Brian Vikings. We're going to check out the fuel in a Bic lighter. We are going to try to experimentally determine the identity of the gas that's in here just by using some pressure and volume, temperature, and the number of moles kind of calculations. If you hadn't guessed, this is the ideal gas law, and it's going to be awesome. So we're going to take this lighter and we're going to make sure it does light. It does have some gas in it. So and then join me over here. We're going to find the mass of the lighter straight away. So you see I placed the lighter on the balance, and then we're going to check it out. 21.4364. Now it's a highly complicated process of filling up a water truck with water. And I'm going to fill it all the way up with water. Hopefully I can get it totally full. Go ahead and top it off. I want to get it right up to the top, all the way over. And then I'm going to place my hand on top of it, seal it. I'm going to invert it so that there are no holes. It's holding just like a column of water, basically. So as long as I keep it underneath the water level, it will be fine. So I'm going to take that lighter, and so now there is no gas in the column, right? Well, now we're going to add, now we're going to add some gas, and we're going to let the gas come out underneath here, and you can see it's bubbling out pretty well. We're going to let it go until it's about halfway. Okay, it should be enough. Now, this lighter is wet, so it needs to get dried off before we mass it again. Sometimes water gets stuck in the top here, so we're going to do the best we can to wipe it down and not depress the little trigger here to release more gas, because that wouldn't be good. What kind of error would that be? How would it affect your data? Oh, good question. In this lab, you do not need to do any propagation of error. I'm not really concerned with your uncertainty. We will just not concern ourselves this time. I think you'll need a break on it, and if you were doing it for your IA, absolutely would do that, but your biggest source of error is going to be your systematic error. I'm not really concerned with the random error. So the uncertainty is not really going to be much of an issue here. So hopefully we bleeded out all the systematic error we could. And let's go check it out on the balance. It's 21.4553. Okay, so that is not good. This is our first one. This is our initial, and this is our final. It's supposed to lose mass. So obviously it gained a little bit water, but not that much. Hopefully that water will still be the same. Maybe, and if I try it again, maybe we'll get a better result. So let me show you how. That's why this first one is usually not very bueno, anyways. So let's see where our volume stands. We're going to mark the level of where it is. So it was about 16.6 milliliters. 16.6 milliliters is what we were looking at. So let's try that one more time. I'm not going to reweigh it again because I'll just take that last value right there. We know that it's bogus, so we'll just try again. So here's our volume right here. Now you can see that these graduated cylinders are actually meant for this because they are inverted right here. So that's 5 milliliters, 10 milliliters, and 15 milliliters. I wish they would inverted the actual numbers. But that is, that was 5, 10, 15. So that is right around 16, right on around, right, almost on the nose. So I'd say about 16.1. It's probably your best estimation. 16.1. Again, we're not looking at the uncertainty here. Success, guys. We look at the lighter. That may have been because some of the label fell off, so we will remove that label on the next run, and we'll see if we can try to narrow it down. So, oh, I forgot to write it down. It is 21.4033. Let's see if we can get another run in here. We're trying to get that label off that says don't abuse this product or try to do weird science experiments with it. You know, we're just going to get rid of that label. I have no idea what the label says. I don't spend much time looking at cigarette lighters. All right, this lighter weighs 21.3660 grams now. We've taken off as much as we could. We are going to reset and try again. We're going to try again. There was a small bubble in that one. Okay, while we're waiting for that lighter to dry off just a little bit, I will tell you kind of the reason why we are not kind of excluding your uncertainty right here. We're trying to determine the identity of a gas. So there's only set numbers of molar masses that we're looking for. You're looking for a molar mass. So it's going to be some kind of grams per mole. So if your answer ends up being 40 grams per mole, then, is it going to really matter if you're plus or minus 1 or 2? Not really. You're kind of trying to get in that range. You probably have a good idea of what gas is in there. This is still a high school experiment, so that's kind of why we're doing that. It leads to the impact of your uncertainty. There's not much impact going on here to try to determine the objective. So the impact of your uncertainty would be low. That's why we're not really paying much attention to it. In the previous experiment, that titration one, there was a big impact to your uncertainty. It could change your concentration quite drastically. But in this one, not so much. Okay? So the IV wants you to make that distinction in your IAs. So more on IAs later. Let's see if we can check this out. Success. The final mass of that was 21.3581 grams. Good job. So it did decrease. We're in good shape. Now we'll look at that volume. If you look at that, that is actually about 17.5. If this is 5, 10, 15, and then 16, 17, and then it's about 17.5 right there. Okay? Actually, I would say 17 point, you could say 5.5, 17.6, 17.6. I'll say 17.6. Whatever, Mr. Russell, I'll write down whatever you say. Just show me what's going on. Last trial, because that first one was bogus. We are going to recycle the final mass from the previous one. Won't weigh it again. It'll be 21.3581. That is going to be your new initial mass. So let's go ahead and do this right now. I hope there's enough gas in here. So no, we're running out of gas. Okay, the final mass of that one was actually 29.2952 grams. That's because I put more gas in here, so that makes sense that the mass would go down some more, a little bit more. So let's take a look. 5, 10, 15, 20, probably 21.1. 21.1 milliliters of gas there. So we have 3 relatively good trials. That first one was garbage. Let's throw that first one out. So I'll give you a hint. Take a look at that data table right there. That should square you away. 2 other very important measurements to take is that right now on Thursday afternoon, October 8th, 2020, there is Hurricane Delta is sweeping through in the Gulf, and we're starting to feel some clouds. It rained a little bit today, so the barometric pressure is a little higher than normal. It's 29.95 inches of mercury. That's 29.95 inches of mercury. So that is somewhere around 101 kilopascals. Why don't you go ahead and look up a unit converter and convert that? So that's what KBTX says. There's my reference, KBTX. Thank you, weather. And so my temperature of the water is, surprise, surprise, probably around the temperature of the room, which is 23.2 degrees Celsius. 23.2 degrees Celsius. Okay, another reason why we're not doing uncertainties right here is because I have no idea what the uncertainty of the pressure is, and the uncertainty of your temperature is going to be so wide that it's going to envelop everything else. So yeah, we're just not going to mess with that. Hopefully you saw 2 systematic errors that happened. I noted one earlier, because of the thing, and the thing that was in the thing, right. Hopefully you got that. So what are some good remedies for that? Let's see, you could produce your own gas instead of just getting off a lighter. Maybe you could check that out. Another thing you should probably kind of think of is that this experiment right here has lots of possibilities for like manipulation for your own IA. You could do an IA off of this experiment just by trying to focus on one specific part and trying to see how much of an impact it has on your uncertainty. You could try it with different gases. Maybe you could produce different gases. Find a different way to do that. You can make a gas in a reaction flask and then bubble it through a tube, and so it produces gas in here. There's lots of different ways you could do that. You could even grab one of these big guys, right, and produce your gas this way. So that's a lot of ways you could really kind of open up this experiment. I wouldn't really adjust temperature too much. You can't really adjust pressure, but you can adjust the identity of the gas, and you could see how it affects your volume. So that could be your measured variable right there. So just try to think about that every time we get to an experiment. How could I turn this into an IA, right, or my own investigation? All right, that should be it. Check out the rubric right here, and you should be good to go. Have a great day.